All right, it is 6:05, and therefore we will go ahead and get started and not waste any more time. Thank you everyone for being here. It's always awesome to see so many people showing up to any of our events. If you haven't already signed in using the link at the top of the link tree, please make sure you do that just in case we need to turn that over to anyone. Let me put my phone on do not disturb since this has caused me issues in the past. All right, so we have 3 quick announcements really quick before we actually jump into things. The first one is not this coming up weekend, but the weekend after. The UCF Robotics Club is hosting a field day, which will be on Saturday at 1 p.m. It's in the very back of the RWC park. So if you go behind the big RWC and then just like keep walking for a long ways, there's a bunch of fields that look like soccer fields. And I think it's like the furthest soccer field down. So if you want to attend, there will be barbecue. We will pay for you to go. So you just have to RSVP so that we know that you're going and bring anything that you want to play with. It'll be a lot of fun. A lot of nerdy engineering students doing athletic activity. So that'll be cool. All right, and then another thing that we kind of randomly decide to do every once in a while is this Sunday, we're going to try and do a Valorant charity stream just for fun. I was recruited by Gila, a vice president who's very interested in Valorant to try and play. I'm extremely terrible. So if you are interested, come watch us struggle play Valorant, which will be on Sunday at 8 p.m. If anyone is interested, I don't think we have a Twitch. I think we're doing it through YouTube. So I would assume it'll be on the Nighthacks YouTube channel, but we haven't really discussed it in completion yet. If you're interested in playing, we'll probably like try and put a team together. So if anyone here is like interested in Valorant, or even if you've never played Valorant in your life, that's part of the fun. So if you're available Sunday at 8 p.m., go ahead and do that. And we'll be voting on the tech charities support throughout the stream. So it'll all go to a good cause. All right, and then other things, after this workshop, please make sure to fill out the feedback form at the bottom. I'll try and remind you before everyone heads out. Cave happens every Thursday, right before this, and operations meetings are right after, although we're not having this one this week. So we'll resume next week.
Show up the cave and be like, I don't know what I'm doing in XYZ thing. I'm like, we're all just kind of sitting there and we'll explain whatever.
It's a good hangout period. All right, that is everything in way of announcements. Thank you for bearing with me. All right, so here we go. We are going to go ahead and do a quick demo of what we're going to build today, just so everyone knows where we're going to. I expect that this is going to require a lot of debugging and will probably take a whole 2 hours. So I would not expect to be out of here any earlier than like 7:45, but we'll try and do our best to get you guys out as soon as possible. But I'm going to go ahead and start this up. And we'll go ahead and see what we have in store. All right, so I'm going to navigate to localhost. And so this is what we have today. So we're going to create a Tic Tac Toe game that you can connect to from multiple browsers. So you're not playing on one specific window. Theoretically, if this were uploaded somewhere, people could connect from anywhere, but because it's running locally on my machine, we can boot it up in multiple different tabs. We can join any game as whatever name we want, and we'll call this room A. And once we join, we're waiting on an opponent, and then we can join as someone else. We can join the same room, and now we're connected. So I'm playing against Eli, and Eli is playing against Phil, and we can go ahead and play tic-tac-toe. And eventually, after I constantly swap tabs, if someone wins, there's a, it'll go ahead and mark who wins. It'll send back all the information that the game is over. And we can either reconnect to a new room, we can refresh the page, we can join something else, but that's what we're headed for. So this will be an interesting application of writing a very simple front end in order to get this working. I think that probably we're going to mostly skip some of the base HTML and CSS, because that's really boring, and I'm just going to give you guys a template, and we'll focus mostly on the actual JavaScript to make it do interesting things. And then we're going to go ahead and create a service that's running so that we can go ahead and give the front end to the user when they go to our base URL, and then also create some extra functions in there just so that we can, try a bunch of really cool things. So hopefully this will give you a good view of how everything comes together, and you can go ahead and make something even more complicated and more cool afterwards. All right, so with that all being said, we're going to go ahead and start with the template that we have. So everyone needs to head over to nighthacks.org/linktree, and there's a link near the top called Workshop Starter Template. And it should take you to a folder of about 4 different things here. I've created some SVGs for the pieces that we're going to play. And I've also created the index.html, which is where our actual site is defined, and some styles to make it not look like shit. So go ahead and just download all of those. And it should download it into a zip file. And we can go ahead and figure out where on our machine that we want to put this. I have a projects folder, and so I'm going to navigate over there. See projects, and then we'll go ahead and make a directory. You can call this whatever you want. I'm just going to call it live workshop because I already have a directory with the name that I was going to use for when I was planning this. And once you have that, you can go ahead and open it in whatever editor you want. I'm going to go ahead and open it in VS Code. All right, so this is not what I wanted to do. Hold on. We'll open the folder, projects, live workshop. Here we go. All right, so when you open this, you can go ahead and open it in a file explorer. If you're not using VS Code, honestly, anything works. You can edit all of these files that we're going to write in a text editor. So like you could literally open these in Notepad if you really want to. There should be no issues. But I have everything in here. What we're going to do first is we're going to create a separate folder for everything related to our client, which is the actual web page that we see. And I'm going to go ahead and take all those things that I just downloaded, which is a zip file. I'm going to go ahead and extract everything here.
I gotta do some.
All right. So the 2 markers are CSS and our index.html. We're going to go ahead and copy them in here. That was a really loud noise. Can I not do that? All right, yeah. There we go. Okay, and then all of this can go in your client. There we go. So this is what we've got right now. It is a very basic HTML page. We could open this right now in our browser if we wanted to, but it would not look like anything, or it wouldn't do anything rather. It would look like the actual page that we have. But let's go through this really quick, just so everyone gets a general idea of like why I've structured it the way that it is. If you're curious about like what any of the elements do or any of the CSS properties, you can go ahead and mess around with them and see what changes if you mix some things around. But essentially what we're doing here is we have our HTML page, which has this HTML tag. It has a heading section, which is all sort of like information that you can't see. We're importing our style.css file, which we'll look at in just a second, but that's where we're going to style all of our elements. We have a title, which shows up on the tab at the very top. So like when you're in your browser, there's a little like heading at the very top of the tab, which will just say Tic Tac Toe. And then we have the actual structure of our page here. So I put everything in a container, and I'm using this container to center everything in the page. And then we have 2 sections. We have a section at the top for the actual form. Actually, I'll just open this up so I can reference what it looks like. So this was our live workshop. And we'll open our HTML with Google Chrome. Cool. So we have 2 sections here. The first section is these things at the top, which I'll zoom in for a second. Essentially, what we're going to do is we're going to give someone a space to write a name they want to connect as, where they're connecting to, a button that submits that form, and then also a button for pinging. We're going to write a very simple route that allows you to do a ping just to figure out how long it takes, just to prove that we can create some actual routes as well. And then the second section down here, we have an invisible piece of text that's going to tell us what the current status of our game is. So is the person connected? Are we waiting on someone? Is it my turn? Is it your turn? We'll go ahead and update all of that. And we have our table. So our table is made up of 9 different cells. They each have an ID property 0 to 8, which is what we're going to be using to reference a specific cell when we want to change it. So we'll do a little bit of interesting math there. And then at the very bottom, we have 2 scripts that we're including. The first one here is not something that I wrote. This is the socket.io library, which allows you to basically connect 2 things together and send messages straight away. So I can just send messages whoever is connected to the same socket will just get everything that I'm sending. And we're going to use this to actually create like a real-time element to our game. So I can play actions that'll send those as messages through the socket connection, and then everyone who's connected to the same game will receive those and be able to do really interesting things. And then the second thing here is a script that we haven't created yet, but this is going to control all of the actual stuff on our page and how it interacts. Cool. So with that being said, we're going to go ahead and create a main.js file inside of our client directory. I'm going to go ahead and zoom in here. Maybe. Is it not going to let me zoom in? Okay. So we're going to zoom in way the hay in here, and hopefully this will be pretty clear about what we're doing. And we're going to do a couple things in here. We're just going to set ourselves up for later. Right now, we don't have any server running in the background that can actually handle our game. So there's not really a whole lot we can do at this point, but we're just going to set ourselves up so you can see generally what we want to control from this main front end script. And then we'll go and do some interesting stuff after that. Okay. So we need to get a reference to a bunch of different things here. Eventually, what we want to do first is anytime that we click on one of those 9 grid cells, we want to do something. And the way we're going to do that is we're going to get a reference to all of those elements, and then we're going to add a listener to it. So JavaScript is kind of interesting. JavaScript is a scripting language, which means we're going to write code in here. It doesn't start from a main method or a main function. It just goes top to bottom, and it executes everything, and then it's done. The way that we can put something in here that's going to be persistent and is actually going to keep running is we add listeners. And listeners will be running on your web page. And when something happens that they're listening for, then it'll go ahead and do something interesting. So let's do a couple things here. First thing we're going to do is we're going to get a reference to all of the cells. I'll explain what this is in a second. Last name, cell. Okay, so a lot of interesting things to pick out here. So if you've never used JavaScript before, you'll notice that there is no type. This is a dynamically typed language, which means we only have to put a modifier in front of it. Constant means we are not going to be able to edit this again. We can't reassign to it. If we wanted to reassign to it, we could use let instead, and that would let us go ahead and change this. But we don't actually care about that. And document gets a reference to our whole page here. So document has a bunch of interesting functions. If we want to look for a specific element in the page, we can do that through the document. We can do it with a couple different methods. So we could do document.get element by ID. You'll notice in here, we've given an ID property to a couple of different elements. An ID uniquely identifies one particular thing, whereas a class, you can give the same class to lots of different things. And classes are useful for grabbing multiple things at one time or styling multiple things at one time, which is actually what we've done in our style.css. We've styled all of the cells to be exactly the same. So let's change this back. So we want this to be get element by class name. So it will return an array of all of the cell elements. And what we said is we want to create a listener so that every time we interact with a cell, it does something interesting. So we're going to go ahead and write a for loop here. I need to close this down because I'm too distracted by it. So we're going to do a for loop. What this does, essentially, let's actually pull this up in the browser just so you guys can see what I am talking about. So I've opened, by inspecting the page, I've opened our dev tools, and I can go over to the console, which allows me to execute JavaScript directly inside my page. So if we do document.get elements by class name and then .cell, you're going to notice that it returns a collection. Oh, that's not good. All right, we're going to do this a little bit differently. Let's do document.query selector all .cell. All right, there we go. So another way that we can grab things is query selecting, which allows us to create more dynamic selectors. So let's change this over here. So we're going to do query selector all, which means grab all of the things that match this selection. And then we're going to put the class in here with a dot to indicate that it's a class, and it'll return all of our things. And then let's do for each cell, and for each loop in JavaScript looks a little bit different. than it would in Java. If you've ever used Java before, this is essentially saying take each thing in our iterable array cells, which means it's like multiple things, and then temporarily assign it to intermediate value cell, and then we can do something with it here. So we're going to add event listener to it. And it's going to take in two things. So if I hover over here, it's going to give us this really disgusting function signature. But essentially, there is a first thing, which is a type, which we can actually fill in as a string. And what kind of event do we want to listen for? We're going to listen for a click event. And the second thing is we need a reference to a function that is going to execute when this event runs. So if you've used Java before, typically all of your methods are going to be related to a specific class. And some languages have functions as first-class objects, which means we can take a function, grab the reference to it, which means I'm not executing it. I just want to know that this is the function I'm talking about, and then put it into a variable for later. So let's do this. Let's create a function down here. Handle cell click. And this is to do. We haven't done anything yet, but we can actually just put in handle cell click here with no parentheses, which means we're just going to give it a reference. And this listener, whenever the listener executes in the future, it's going to do whatever this function tells it to do. So let's console.log test here. Just to see if this works. And I already have the index.html page loaded up here, but if you don't, you can go ahead and open it from your file explorer in a browser. I'm going to reload this. There's going to be a bunch of disgusting things here that we're not going to look at for a second. Is this actually bad? Okay, we're going to ignore this for now. I hope that we'll be able to figure that out in the future. But now if we go ahead and click on any of these, nope. All right, this is going really well, guys. What did I do? So add event listener. What if I do this? All right, so this is sort of a shorthand here of declaring a function. It means that we're taking in no parameters. This is an anonymous function, which is just shorthand. It doesn't have a name. And then we go ahead and execute something in here. And our function is in curly braces. And then if I reload this now, why isn't this doing anything? Oh, so I can't get the main.js. So why doesn't it like this? Right now, our script is not being loaded up for some reason. Okay, we're going to leave this for now because I think that this is going to get fixed a little bit later. And we're going to go talk about some more interesting things right now. So there's a bunch of other stuff that we can do in here. Right now, we're just going to leave this as a to-do. We'll do this at a later date. But right now, I really just want to get to the point where we can set up our server, which is a really interesting part, and then actually give this front-end stuff directly from the server, which will eliminate all of this, all of these disgusting error messages. Because what this is really telling us right now is that it can't like find the other files that it's looking for just because it's like the project structure is really strange. So what we're going to do is we're going to go ahead and open up a terminal, new terminal. All right, and I'm going to navigate in my terminal over to the same parent folder here, Live Workshop. If you open just a normal terminal, you'll have to cd into it, but VS Code will just take you in there by default. And hopefully everyone has Node installed on their computer at this point. If you don't, it's very easy to do. You'll just have to spend a little bit of time. But once we have Node installed, we can npm init, which creates a new Node project. It's going to give us a bunch of things in here. We'll keep the same package name, version, description, entry point, test command, git repository, keywords, author, license. None of this is important. If you were going to actually publish this somewhere, you would want to fill those in with serious values. But what this will do for us, it will create a package.json file. And the package.json is where our node project starts. So by default, JavaScript is only really executable in the browser. It gets used for front-end web pages, and that's what it is created for by default. But a bunch of people have decided that it'd be cool if we could run JavaScript anywhere and do anything with it. And so that's what Node is for. Node is a runtime environment for JavaScript that allows you to just execute whatever you want and do interesting things with it. So there's a lot of different applications. You can use Node if you want to use a JavaScript framework, like if you've heard of React before. It's a different way of creating your front-end web pages only in JavaScript. None of that exists in normal vanilla JavaScript and HTML, and therefore you have to use Node to build it and a bunch of interesting things. But it also allows us to do other things like create a backend service, which is exactly what we're going to do. So we're going to install a couple of other things here. And the way we do that is with our npm command. Again, we'll do npm I, which stands for install. And we need to install Express and a couple of other things that I forget exactly what here. All right, so if that worked, it should give you that it added a ton of packages. And you'll notice that in our dependencies section of our package.json, which defines everything in our project, we now have Express as a dependency. We can also install HTTP. I'm just going to put these all in one line because otherwise we're going to have to install them individually, which is going to be a huge pain in the butt. So we're going to install 3 things here, and we're going to use them at varying points throughout the event. HTTP allows us to create a server, which is going to be useful for our socket connection. Nodemon allows us to run our backend server and have it automatically reload without us constantly having to stop it and restart it. And then socket.io is what we're actually going to use to create our socket connections. Okay, so we have all this in here. And with that being said, we now have a node modules folder in here. And this node modules folder is where all of these things have been installed. People have created all of these, their JavaScript libraries. And eventually, when we run our thing, it's going to use those libraries. And then when we want to actually build it and send it to a production environment somewhere, it's going to take all of the code that we end up using and directly insert it into the built thing. This all compiles down to just vanilla JavaScript eventually. There's a bunch of people that have come up with very smart ways of doing that I can't even begin to explain. So with that being said, let's go ahead and create the first thing we need, which we need an index.js. If you look in your package.json here, one thing that we agreed to is our main or our entry point is index.js. So this is where it's going to start. And once we've created that, we also need to put a script in here. So our scripts are what we can use npm run something. And it's going to run a script, and we can specify a bunch of things that we would want to run in our command line, but we can shorthand it as just a script. So what we want to do here is we want to run node index.js. So node is the command that actually executes this JavaScript file in the node runtime environment. And then we are saying that we're going to shorthand this with npm start. And I think I accidentally clicked run. I'm going to close this down for a second. So we got all this in here. We have our starting script, we have our entry point, and now we need to actually do some cool stuff. So we're going to import Express. Here we go. Sorry, one more thing that I forgot in here. In our package.json, we also need to specify a type, just not in here by default. And we want to specify a module. The reason why we're doing this is there's 2 types of ways that you can handle imports and exports. The old version is using CommonJS, where you have to use like a require statement. And it's not super helpful because when you require it, VS Code doesn't help you with the things that are part of the library you're importing. Whereas if we use a module syntax, which is the newer version, then everything that we import, it'll automatically give us hints about what we can use from this package. So we are importing from this package we installed, we are importing everything. There's 2 types of imports. So we need to npm init, which creates the whole project and gives you your package.json. And then we need to npm I, which stands for install express http node run socket.io. Those are the 4. And then we have our module syntax here, and this means we can just use an import statement rather than require. So what this is doing is we have our Express library that we installed, and there's 2 ways in module syntax that you can export things from a file. So let's say I had a variable here, and we had another variable here. In this file, we have multiple things that we would potentially want to export if this were a library for someone else. And in that case, we can export them, which means other people can import them and use it using named exports. So we would say we are exporting A and B in curly braces, which specifies that it's like the name of the variable. And then if someone were to use this in another folder here, let's just create something really quick. We can import from .. I think I put it in index.js. Yeah, here we go. So we could import from that. And in order to do so, we would need to use curly braces again and import specifically A and B, or we could only import A, or we could only import B. So that's how you do named exports. But this particular library has decided that they're going to use a default export. So if you have one thing that's coming out of a file, you can export default A, which means that's the only thing coming out of here. And when we import, we don't need curly braces, and we can call this whatever we want. It'll just give us back whatever object is being passed out. So that's why we're not using curly braces here. So we're importing Express. We need a couple other things in here. We need to import HTTP from HTTP again. It's another thing that we installed. Let me just make sure there's nothing else that I'm missing. Not right now. Okay, so there's just some lines of boilerplate here that there's not really anything we can do about. In order to use an Express server, we first have to instantiate it and then assign it to a variable. We can create a server from our http.create server, and we can pass in the app that we just instantiated. Under the hood, there's a bunch of stuff going on here that I don't entirely understand either. This is just what we do at this point. We need to specify a port, which is what port on our machine are we going to be able to connect to this server from. We'll just arbitrarily pick 3000. There's a bunch of naming conventions about why you would pick which one. And let's do 2 things. First thing we're going to do is we are going to specify a middleware, which means if I am connecting to this server and I go to this particular route. So right now we can always connect to our server using localhost and then the port that we just specified. This is the URL that we'll actually use to connect to our server. And then this means it's just a blank route, so we don't have anything after it. And in that case, we want to serve what our front end that we created is. So we want to give them all the HTML and CSS. The way we're going to do that is with express.static. And then we're going to specify the client directory and everything in it. So what this is going to do is if they go to the base route, it'll just go ahead and send them all of the vanilla HTML, JavaScript, CSS. And another thing that we need to do is we need to go ahead and start our server. So we need to listen for it, and we'll listen on ports. All right. And this might be a little confusing about what's going on here. So we are going to go ahead and create our server. We're going to listen, which means we're taking in requests now. We're going to run it on this particular port. And again, the second thing here that it takes is a function reference. And all this is going to do is when it comes back and it successfully works, we can do something. And all we're going to do is we're just going to console.log. Hey, it worked. It's running right now. Great. So this, again, is an anonymous function, which means it doesn't have a name. It's just one line. So we don't have to have curly braces around here, but this is functionally exactly the same. We'll go ahead and put curly braces just so it's not confusing. And when it comes back, it'll just go ahead and print this and we'll be good to go. All right. So you have a backend server right now. It's very simple. It doesn't really do anything, but we can go ahead and run it and actually see that it works. So I'm going to open my terminal again. And once again, if you're doing it in VS Code, then you can just open it straight away. Otherwise, you'll have to navigate back into this parent directory here. And we can npm start, which is that script we created. Remember that. And if we go ahead and do that, it'll go ahead and do some stuff, and then it'll print us out the thing that we printed at the bottom. The server is running on port 3000. And right now, we have it set up so that if we go to the base URL, that it'll give us our front end. So let's see if that actually works. HTTP, localhost 3000. And it'll go ahead and give us our front end here. And once again, there's some stuff in here. It can't load up our socket.io script, which we'll have to figure out what to do about this later, because this should not be happening. But that's a problem for another time when we actually have something to work with. All right. Is anyone behind? Does anyone need to see something, slow down, catch up? If you go back on the link tree, there is a link for full workshop code, which sends you to a Git repository with everything that we're going to write in here. So if you ever need to catch up, that would be a great place to go and see what you're missing. But again, raise your hand if you're stuck. We'll go over it as a group. Okay, so we have our server. Let's do something else really quick. Let's go ahead and create a really simple route just to prove that our server is working, that we can connect to it. We're not actually going to use this for any serious purpose, but if you were to create like some API routes, like if you wanted to, let's say you had a database running and you wanted the user from their front end HTML to be able to like perform some operation. What you do is you would design on your server an API route, and that route has a specific URL. It has a specific method, which means what is it going to do? And then you go ahead and send the request. The server will go ahead and do whatever it wants. It'll come back and send you some stuff back. What's up?
I got some errors when I did npm start.
Okay. What is the error that you have?
Did you mean like one of these and then did a bunch of that?
Okay, so in that case, your script doesn't exist. So just make sure that you have added to the script section of your package.json starts and then node index.js. Right now, it has a test script in there, which does nothing. That's just the default. So we can replace that.
Even after changing that, I'm still getting the same error.
That the script doesn't exist.
Yeah.
Try it again. You're in the right folder, so theoretically it should just work. That'd make everyone's life easier. Make sure you save your package.json. It should just put all of that in by default. Not all of this is super important. As long as you have the script section and your dependencies, that's it. That's confusing. Hold on. Okay, so this is not, I don't know what that's coming from. No, this is a correct voice. All right, like if it's gonna throw you any errors when you train, you'll have to put in that script section and probably the main and the type as well. So those three things together. Probably everything else is optional, but if you try and get started, it tells you this then like. Okay, so you created your package here. Right now, we don't have our new modules for our package. So you can create your package that JSON way. Okay. So since nothing's being here already, let's go back to the steps of creating your package.json. If your package.json isn't working or doesn't look like this, don't worry about it. And we'll go ahead and do this the right way. So I'm going to go ahead and delete this really fast. So package.json. And then in our parent folder, so not in the client folder, but just in the main thing. And let's pretend that our node modules don't exist or the package lock. So we have nothing. If it doesn't work, go ahead and delete everything. We're going to run npm init, just that one command. And it should give us a bunch of prompts here. So it'll give us the package name. We can just click enter. We're just going to click enter through everything. It'll just put all of those in as default. And it should generate us this package.json. So that's that will come. So when you npm init, it'll not put anything in there. So pretend that none of these dependencies are in here. I would delete this, but it'll take a long time. It's all right that you don't have anything. You need to run npm install for all of those things that we wanted: HTTP, Express, and socket.io. And that will go ahead and generate your node modules and your package lock.json, which is just like the format of everything. All right, I got to keep moving. If anyone is getting stuck, use your resources around you. And we can go back to things as well. Okay, so we have this in here. Theoretically, when you go to your main route, it should just give you this. We're going to create another route in here, and we're going to make this a get route, which means I want to get something from the server and send it back to me. And we're going to arbitrarily say that this is going to be at /ping, so localhost 3000 /ping. We can choose whatever URL we want. And then we're going to again specify an anonymous function, which is going to be our callback, which means when we go to this, what is it going to execute? And this has two properties. It has a request object and a response object. In JavaScript, we can name parameters whatever we want. So it'll pass in two objects. We could call this Bob and this Phil. It doesn't matter. But this is our request, which means all the data about the front end sending to us. And then our response is what we're going to use to send data back. So in this case, we're going to do something really simple. We're just going to send back a status of 200. Every time that you send something back, it's going to have a status code, which means what happened. And then it's going to have data with it that specifies like what exactly happened. So our 200 code, if you look up HTTP codes, all the codes mean something different. 200 just means everything worked. And we will go ahead and send back, we'll just send back a string that says Pong. So they send us ping, we send them back Pong. Very, very simple, nothing crazy here. And that'll work. If we wanted to pull data from the request, we could do that. If we wanted to send extra data back through the response, we could do that. You can go ahead and Google that on your own time. All right, so we have this. I'm going to run npmi here, just make sure I have all the rights. I should already have everything here. All right, great. So we're going to go back into our main.js here. We're going to create a function just to test this out. So we'll create a function ping. And we will go ahead and fetch, which is how we send a request with JavaScript. So this is our front end communicating to our server. And we could specify what specific URL we want to fetch from. If we wanted to fetch from an outside API, we could do that, but we don't need to. So main.js here. We are, which function is it? Great. Okay, so we're going to fetch from our localhost URL 3000, and we're going to fetch /ping, which is that route we created. And we need to, we could create multiple routes at the same URL as long as they're a different protocol. So get, again, means I'm getting something from the server. There's put, which means I'm sending something to the server. There's lots of different routes. So we need to specify the method, which is get. And that's it, I think. What did I do wrong here? Oh, no. So this is an object. In JavaScript, we can create an object very simply. It's just anything in curly braces. And so it has one key, which is the method. And the thing that we're doing is we're getting, this needs to be capitalized actually. And we will await for this, which means it's going to take a little while. It'll come back to us eventually. And we need to, all right, this is messy. We're not going to do this. Sorry, I lied to you. Let's do this instead. So we have fetched, and we're going to use an interesting pattern here of handling what are called promises. This has turned into much more of a low-level learn JavaScript than I was expecting it to, but this is really important. So in JavaScript, we can do things asynchronously, which means I'm going to run this thing and it'll take some time to come back to me. I have no idea how long it's going to take. And we can decide whether we want to wait for it, which means don't execute everything else. Because again, it's a scripting language, which means JavaScript goes top to bottom, which means, so we can await for it, which means don't do anything else until this comes back, which is who knows when. Or we can let it go and just specify to our request, like, when it comes back, then what will it do at that later date, whenever it is. So the first thing that we were going to try and do is we could await for the fetch. And then this would like prevent us from executing anything below. So if we console logged here, it would wait for the thing to come back. But since there's not like multiple things going on here, we're going to do it the other way. We're just going to specify when it comes back. Who knows when that is? We're going to do two things. The first thing we're going to do in our first then, we can chain multiple thens together, which means just do this thing, then this thing, then this thing. We're going to take our response objects and we are going to call res.json, which takes the object, which is a very disgusting format and we can't do anything with it, and it turns it into just a JavaScript object, which is really easy to handle. And then in our second one, now that we have this, so this is our response res object. And this will now have all of the data that we decided to send back. And we decided to send back just a string here. Actually, this is not going to work. All right, sorry, we're going to change this up just a little bit for simplicity. We're going to go back in here. Instead of just sending a string, we're going to send back a JSON object. So this is going to send back a whole object, and when we call .json, it'll give us this object back. If we called that, it only sent back a string, then it would cause a problem. So we're going to, now that we have our object, we're just going to console.log res object.ping, which gets us back the string. So we're accessing the ping property, which gives us back the string pong. And then we're going to append on here. Milliseconds. And we need to figure out what X is. So we're going to do two things here. We're going to create a variable up here, start time equal to new date. So a lot of things going on here. A date is how we represent dates and times in JavaScript. And this is a really complex type, and getTime just returns the time in milliseconds, which is a really great way of getting a timestamp. So we're going to save that. And then after it comes back to us, we're going to get our end time, new date, get time. So when this is eventually executing, who knows when, it'll get the current timestamp. And then in here, instead of X, we're going to do start or time. It's going to get the difference between our timestamps. Okay, so we have this function. Currently, it's not doing anything. So let's go back in here in our index.html. There is a button here that I put in called test ping. So we want to go ahead and execute this function when that gets called. So let's do two things. First, let's go ahead and get a reference to the element. Ping button documents. We can select it a multitude of different ways, but because it has a really easy ID property, we will go ahead and get, sorry, it's too many things open here. We will get element by ID. And because it's an ID, we don't need to specify, like normally if we want to select an ID, we'd use a hashtag, but because it's specifically IDs, we can just put in what we called it, which was test ping. And we can go ahead and do ping button dot add event listener. And when it is clicked, we will go ahead and send it to our ping function. And again, we don't want parentheses here. If we put parentheses after this, it's going to literally try and execute it in line there, which is not what we want. All we want to do is give our listener a reference to our function so that it can call it at a later date. So with this being said, go ahead and save this. I have my terminal here. So we can go ahead and npm start again to run our server. We don't need to rebuild our front end or anything. Oops. What did I do? Oh, I forgot to recreate the script here. You guys should already have this because we already changed things, but I deleted everything. I go down to the script section. And we had our script down here, which is start node index.js. Okay, I'm going to actually create another script in here while we're here. We're going to call this dev, which is going to run our development server, not in a production environment. And we're going to use Nodimon, which is the other thing that we installed. I don't think I have in here. So I'm going to npm I Nodimon. And Nodimon just allows it to auto reload, so we don't have to constantly start it and stop it. And we'll Nodimon index.js. Okay, so we can do two things here. First, let's do npm start. And now if we go to our localhost and we click the ping button, it'll send us back. You can't really read this because it's so small. But you should notice in your console that it sends you back the Pong string because our handler actually ran, and it'll give the difference in time between when you sent the request and when you got it back. So we can test our latency, which is great. We can do this as many times as we want. It'll give us different numbers every time. But now that we have this, we can go ahead and stop it with Control-C. And then we can npm run dev. Start is a special script. You don't have to put run in beforehand, but any other script, you'd have to do npm run and then the name of the script. And so Nodimon has all this extra stuff in here that says it's watching, which means if we were to go ahead and change, let's put some extra lines in here and save it, you'll notice it'll automatically restart our thing and it'll give us back our starting message. So we don't have to constantly like start and stop and start and stop it. I am unfortunately going to stop it right now just because it's going to try and do it, reload it multiple times for things that we don't want. Cool. So we still haven't done like any of the actual game part yet. And it was almost 7 o'clock. So it's gonna be so long. Okay, so where to start here? I think what we need to do first, if I'm looking back at our game here, is we need to actually have a way for people to connect to the game. And we can worry about the actual gameplay elements later. But we want to first create our socket connection just so you guys can see how sockets work and what you can do with them. And then after that, we'll go ahead and create all of our game logic on our server and allow people to actually play. So let's do this front to back. So let's start with our main.js here. And we need to get a couple of other things. We need to get a reference to both of our inputs, our name input and our code input. And then also a reference to this form element. A form element just means we have a bunch of inputs in there and we have some way of spinning them, which in this case is with our button. So anytime we click the button, anytime we click enter, it's going to submit the form. And so we need a reference to the form element so we can get the event when it's submitted. So let's do a couple things here. So this is called start form. So we'll get start form document dot get element by ID start form. I'm going to name these the same thing so that it's immediately clear what it is. And then name inputs document dot get elements by ID name inputs const code inputs document dot get element by ID code inputs. Let me just make sure that's what I called everything. Name input, code input, start form. Great. All right, so we have all these things. So we're going to use our inputs eventually to get whatever is inside of them. But the thing that we need to do right now is we need to listen for when our form is submitted. So we're going to do that with start form, and we're going to add another event listener. And this event is different. Rather than clicking on something, we just want our form to submit. Why is this so large? And then our second thing in here, again, is just a function that's going to get executed when this happens. And so we can add a parameter in here. The parameter we're going to add, we're just going to call E, but this is a reference to the actual event that's happening. Any event has a reference to that. And we're going to use it here to call event.prevent default. So normally if I try and submit a form, it's going to reload the page. That's a default behavior. We don't want to do that. So we're going to prevent it from reloading. And we are going to get the username from name input.value. Our HTML element input, we can call .value and get whatever's currently in there. Same thing for game, for code, our code input.value. All right, and then we need to do a couple things. We need to submit a request to join the game and take back whether it worked and what player number they are. All right, so these are all things that we'll need to do at some point, but we don't have any way of doing it yet because we don't have any socket connections. And so that's our next step. So we have already installed, hopefully, socket.io. If you haven't, npm I socket.io. And we're going to go into our parent directory, and we're going to create a separate file for handling socket connections, since there's going to be a lot of code in here. And we're going to create a function in here. Default function start socket server. And again, because we're only going to export one thing from here, we're going to export the function that actually starts it. And then all the code for the socket stuff is going to be inside here. We can export default, which means only one thing. And right now we'll just to do. And now that we've exported this, we can go back into our index.js, is where our server is defined. And we can import, because it's a default import, we don't need to put it in curly braces. We can call it whatever we want. We'll call it start socket server, just to keep it familiar. And VS Code is going to auto import that for me from socket. All right. So now that we have that, we need to do all kinds of interesting things here. I'm going to head over there on my agenda just so that we can make sure that we're doing this correctly. All right. So one thing we need to import here, we need to import the server. Sorry, that's not the right server. Server from socket.io. This is a named export. There's lots of things that come out of this package, this library. So we need to get the server. And we are going to create a new socket server and assign it to a variable. They recommend IO, so we're going to stick with that. We can do some interesting things here. So we can do io.on. So our socket, our IO is like the server that's actually running and handles all of our socket connections. And so we can listen for specific events. And essentially what this means is I'm sending a message. I'm going to put it under this event, which means you can send events for anything that you want, any string that you define. And then if we get something for that event, we can take in data that gets passed and then do something with that data. So there are a couple of events for this socket server that are predefined that we can use. The one that we're going to use right now is on connection, which means our socket is first connecting, and then it'll send us more data after that. And there's no data that we take in here because we don't need anything. So we'll just create this as an anonymous function by default. And we'll do, sorry, I lied. We need to put a reference to the actual socket object that is connecting, which has a bunch of properties that we'll use later. So let's see that this works with socket.id, sorry. Is this right? Yeah, I'm right. Okay, So what this is going to do is every time we connect a new socket from our client, it's just going to log the ID. And if we run our server right now, nothing's going to happen because there's no sockets connecting. Our socket connection has to come from our front end HTML. And we're going to do that with our JavaScript. Stop buzzing at me. All right, so we're going to go back into our main.js here. So this is back into our client. And we're going to do two things. So you'll notice over here, sorry, I'm getting lost in my own projects. You'll notice that we have imported a library at the bottom, socket.io, socket.io.js. And this is so if we go in here, this doesn't look right to me. Hold on. We're going to look at the client API here because this does not seem correct. Okay, here's what we're going to do. We are going to run another installation command. So we already npm I socket.io. Oh, we don't even need to. This is great. All right, so we already installed our socket.io here. So what we can do is we should theoretically, in our front-end JavaScript file, we should be able to import io. Get the syntax of this correct. We don't even need to import it. So this index.html, basically, when we put a script tag, it's going to literally insert the JavaScript into our page, which means we don't have to import anything. Everything is accessible. So we can access everything in here from our main.js. We're going to do that. We are going to, let's go underneath all of these things at the top here. We're going to create we're just going to call IO, which instantiates theoretically a new socket instance from our clients. And by default, we could specify like a URL that it's going to, but because they're both running on the same localhost 3000, we don't actually need to do that. And now that we have this, we can do all kinds of interesting things with it. And we're not going to do any of that yet. This should be enough to establish a connection. So let's test this out. So this is just anywhere in your main.js, and we'll go ahead and npm run dev, which will make our nodemon. What is it not like? Sockets index.js. Oh, I messed up. So in here, I just called this socket. This should be socket.js. All right, so this is running now. And if we reload, we're still going to have the issue of where it can't find this thing. This should just work. I don't know why it doesn't. Hold on, let me go back here. Why doesn't this work? All right. Let's try this. We're going to install the socket IO client. which I didn't think we needed to install separately, but maybe we do. Nope, that wasn't it. Hmm. What does this even mean? The MIME type? All right. We're going to do this the hard way. I'm going to go ahead and delete everything in my node modules folder. So I'm going to go into my project, live workshop, node modules goes in the trash, package lock goes in the trash. I'm going to go back into my package.json here. I'm going to take everything out of my dependencies. We're going to start fresh because all of this is garbage. And so npm I express http socket.io socket.io/client nodemon. npm start. So why? Okay, so this is telling us that it's trying to load a script, but this doesn't exist, but it should exist. And I don't really know what to do about it at this point. Socket.io, socket.io.js. Is there something else that I'm missing, maybe? Let's go into our... Oh, I'm an idiot. Okay, so you'll notice here, if we go into our socket thing, we created this function that does this great thing of starting our socket server. And then we did nothing with the function. And so we didn't start our socket server. And so now when it's trying to find it, it doesn't exist. So we're really smart. So we exported this function. All we need to do is we need to import. We already imported socket server at the top here. If you didn't already, go ahead and do that. But at the bottom, underneath where we listen, we just need to start socket server with the server variable over here when we did http.createServer. So now npm run dev. Oh, that's not gonna work. Nope, that doesn't. Okay. Is this different? New socket. I don't think that this should be new socket. I think this should be new server. So we're going to take in our server, our HTTP server here. Sorry, there's a bunch of things that I screwed up. But we're going to take in to our start socket server a reference to the HTTP server. And then we're going to give it so that socket IO can create its own thing. And then it's just going to run. And again, in our index.js, which is where our Express thing is running, we're going to start it and we're going to give it our HTTP server here. So now we save this. We go in here, localhost. All right, takes away all of our disgusting errors. If we go in here, you'll notice that what we did in our socket server is when something connects, we just print out the ID, and it's this disgusting thing here of characters. So it works. We now have a socket connection. It only took us an hour and 11 minutes. We still don't have any of the really important stuff here, so we're going to go ahead and do some interesting things. Trying to figure out what the next thing to do here is. Let us, all right, so let's create a new file in our parent directory called game.js, and we're going to use this to define a game class. And this is going to have a bunch of interesting things in here, but we're not going to put any of those things in yet. We're just going to give it a default constructor, which means it's not going to do anything. And we're just going to use this as a reference until later, and then we'll build out the logic from there. So next thing on the agenda is we need people to actually be able to connect to our game. And the way we're going to do that is we're going to go back into our client here. And when we add our submission listener, we're going to take the username and the code, and we're going to submit it to our socket server and tell it work its magic. So first thing we need to do is we need to submit a request to join the game. And so we're going to do that. We created our socket here. So we're going to use socket.emit, which means send out some event. And we can send out whatever event we want. For sockets, usually you want to submit like your own event. So we were previously listening for a connection, which is defined by socket.io. But here we're just going to call this join game arbitrarily. And we can do a bunch of things here. Just want to make sure I'm doing this right. I was not doing this right, so I'm glad that I looked at it. Okay, so when we emit, we can take, if we look at the functions, it's not going to give us a function signature, but essentially what we can do is we can put in as many pieces of data as we want and send all of those with our event. Doesn't matter how many, we can put them in order. So we're going to send it our username, we're going to send it our code, and we could submit more things. Another thing we're going to do is we're going to give it a function. And this function we're going to use as what's called a callback, which means eventually when this goes through, we want our socket server to be able to send us something back just to acknowledge that it worked or it didn't work. And so this function is going to require some sort of success indicator that comes back, which will have as a Boolean, and then we will console.log success. Great. So that's what we've changed in our client. We've emitted a join game request. And let's go back into socket.js, which is where our socket server is running. And inside this io.on connection, we now have a reference to an individual socket. And we can do anything with this socket. So we're going to, for every single socket, which is why we're putting it in here, we're going to listen for an event. So again, socket.on, same as our socket server IO. So anytime this socket emits a join game event, we're going to do something. So this one does have a function reference, and it's saying that there's two things that it accepts. It accepts the name of the event, which we're calling join game, and then a listener for when it comes through, what is it going to do? And we sent it three things here. We sent it the username that they are connecting as, the code, and a request for them to send back an acknowledgement. So we're going to put in here the username that we sent, and then the code that we sent, and then our callback function. Yeah, and that's the right order. Cool. So we need some way to actually store every instance of our game that is currently running. We're going to use that with a map. We're going to call this active games. And a map is a built-in data type. If you've done any hash maps before, this is very similar. You can put things in and everything has a key and a value. So you can always reference something by the key and the value is what you're actually interested in. So in this case, our key is going to be the code of the game. So we're going to let them determine what the code they want to call it. And then the value is going to be the actual game instance that is running under that code. So what we can do here, now that we have our username, our code, and our callback when they join, we can first check if active games.has code. So has is going to check, is this key already present in the map? If the game already exists with that code, we want to tell them, no, you can't create a new one. That would cause us problems. So we're going to immediately send to our callback function false, which means it did not work. Do not assume that I put you into a game, or return to get out of here early. Otherwise, if that game does not exist, well, we can create a new game. And I don't think that we have imported game yet. So let's do that. Let's go up to the top and we'll import game from game.js. And if we go into game.js here, we didn't export anything, so we will export our game object. Okay, so we've imported our game object. We have created a new one if the active game does not already exist. And we will go ahead and, in this case, we'll call back true, which means that it worked. And again, we don't have any logic in our game, so we can't actually like put them into it yet. All right, this is so far behind. We're gonna have to take some shortcuts, I think, in order to make this actually work on time. All right, here's what we're gonna do. We're gonna cheat. I'm gonna go back to our link tree here. myhacks.org/linktree. Go to our full JavaScript workshop code. We'll go into our game.js, and there's a lot of things in here. All of this is just me defining what our game needs to do. We'll run through this really briefly, but I'm just going to copy and paste this into our game.js. Everything in here. So there's a lot of things in here. We've created another object for our player. So every player has a unique identifier, which is the same identifier as their socket connection, so that we always know if this socket is part of the game, well, then we know it's the right player. We have their name, which is whatever they decide to call themselves, and we have their number, which means either player 1 or player 2. And then we have our game object, which has a bunch of different things in here. So we have a reference. For our game that I've decided we need to have a reference to both players, the player objects. We need to identify who is actively playing, whose turn it is. We need to have a reference to what the current state of the game is. Since it's Tic Tac Toe, it's just a 3x3 grid, so I'm going to make this a 2-dimensional array. And then our winning trio means when it's finished, what are the 3 cells that won, and then our game over if the game is finished. And there's a couple things in here. There's a function for playing a move. There's a function for getting the current state of the game. There's a function for checking if the game is over. We'll use all these in a second. So let's go back into socket.js here now that we have all of that. And when we create our game, what I have decided we need to pass in is a reference to the player 1 and the player 2. So we're going to pass in a new player object as player 1. And then for player 2, we'll pass in null for now because there is no player 2 yet. And we need to pass it an ID, which we're going to get as the ID of the socket that's actually submitting this request. And then we need their name, which is what the username is. And then what was the last thing? We need whatever player number they are. We're going to give them player 1 since they created the new game. We're going to take this new game. We're going to put it into active games, our map dot set. And the key is the game code. And the value is our new game. And so this is now registered. The player is registered as part of this. And let's do one other thing while we're here. Eventually, what we're going to do is, in order to send data specifically to the people that are part of this game, we're going to put them in a room. So an interesting thing about socket.io is you can send a message to one specific socket, or you can send a message to a room of socket, which means everyone who's in the room that you have placed into the room manually will receive that message. And so what we're going to do is we're going to create a room for every active game. And the ID of that room is going to be the game ID. And that way we know if there's an update to this game, we can submit an update event, which has our new game state, to that room, and everyone who's playing will receive it. So we need to do that first. We need to actually submit, we need to put them into the right game. So we are going to io dot, we're going to do socket dot join, and we're going to join them to the room code. All right, and then we're going to put this in here for later. If we want to submit something to this whole room, we're going to io dot sockets leave. io dot to our room, which is under the code, and then we are going to send to them. We're going to emit. We're going to call this update game, which is what we're going to use for any time we have a new state of our game. And we're going to get our active game dot game state. Sorry, I think I called it current. Nope. New game dot current state. So every time that our game changes, we're going to submit the entire game state, which if you look in here, we've created a getter, which just returns all of these things put together in one JavaScript object. So it's going to send back whoever's playing. If someone else joins, that is an update event. If the active player changes, that is an update event. If the game state changes because a move got played, that is an update, that kind of thing. Cool. So this works. There's one other condition here that we haven't accounted for. So right now, this join game will just look if the game exists, and if the game does exist, it won't let us do anything with it. If the game doesn't exist, then it'll know that we can put a game there because that ID isn't already taken. But what if that game does exist, but they just don't have a player 2 yet? All we did in this case is we created a game and put them in as player 1. So we also need to account for the fact in here that maybe the game is already active and someone has created the room, but no one else has joined it yet. So if we have that game code, we need to check. Let's get a reference to it. This game is equal to active games.get code, which gives us the whole game object. If this game.player1 player 2 is, I'm trying to figure out what's the best way to do this here. I'm going to write this and then we'll explain it afterwards. All right, so what this is going to do is JavaScript is also funky because you can make anything a Boolean, literally anything. There's like the concept of truthy and false. Truthy and falsy values, like 0 is like the falsy equivalent of false, whereas anything that's not 0 is technically true. There's all kinds of weird type coercion that we're not really going to get into. But one way that you can do this is if you just put a data type into a condition, if that data type is null or undefined, it'll return false. And if it is defined, if it is something, then it'll return true. So in this case, this is shorthand for if player 2 is not equal to null. This is the exact same thing, but we're just making it shorter, which means if player 2 is defined, then the game's already full and we don't want to join them. Otherwise, if it is not full, then this game dot player 2 is equal to new player socket dot ID username player 2. And we went ahead and did that. And let's do one more thing here. We're going to define a variable called player num, and we're going to use this to send back to the player that's joining what player number are they, so they know whether they're 1 or 2. So in the case of where they're joining a game that's already in existence, then they are going to be assigned player num is equal to 2. And in the case of where they are creating the game for the first time, so we're going to make this an else. So if the game does not exist, we'll do all of this stuff. We'll create the new game and emit stuff. In this case, we're going to assign them player 1. And now, so we have our callback, which you'll notice is just a reference to a function. We originally only gave it one value here, success, whether it worked or it didn't. We're going to put another thing in here, and we're going to pass back the player num, just so that they have a way of knowing what number they are. So in this case, for every time we do our callback, we will go ahead and also return player num. And that way, when this function finishes executing, it'll send back true. It did work. We connected you to a game, and this is the player num that we connected you to. You might notice that we're not actually sending any data about the game right now. What we've done is we've connected them to the game room that they need to be in. And actually what I'm going to do is I'm going to take this. Sorry. I'm going to take these two things, join them to the room, and then also emit to the room that there was a game update, and make sure that these are in the same order. We want them to be able to receive the message right after they join. And we're going to put it outside the if statement so that either way, whether they're creating a game or they just joined one, we go ahead and join them to the right room, and then we call back and say this is player. So they will get this update game event, and they will get all of the game state from that. All we need right now is just to tell them what number they are, so that when they get that game state, they know how to interpret it. Okay, this is really complicated. So let's do a couple things here. We did all this stuff right now. We have our success, we have our player number. Let's check if success was true, meaning that we got something good from it. So if it was successful, we'll go ahead and store their player number here somewhere. We're also going to store our active game, which will come back later. We're just going to create all the things that we need to store. So what is the game they're currently playing? What is the code at that game so we can submit things to it? And then also, what is the number of their player 1 or 2? So if it was successful, that means we got something realistic for a player number. So let's call this join number instead. And we'll put it into player number. Join number. So this will no longer be null. Our active game, we don't have anything yet. That update will come somewhere else. And then our game code, since we know that it actually worked, this code that we submitted and said, try and join a game, we'll go ahead and sign it to game code. And we're going to create another function here called update header, which we'll use in a second. And essentially what we're going to do with this, I'm missing something. Oh, I'm missing a curly brace here. Maybe not. At the bottom of. No, why don't you like this? Okay. So here we go. So we're going to create a function down here, update header. And we're going to use this to, we're going to use this, if you look in here, we have a header element defined, which currently doesn't have anything in it, but it's game status. And we're going to use this to tell the player what is currently going on with their game. So we need to get a reference to it up here. Const header is equal to document.get element by ID. What did we call it? We called it game status. And I'm just going to call it game status to keep with the theme of calling it the same thing as it is labeled. So now we have a reference to header elements. And so in here, we're going to set the inner text to be something. Game status dot inner text. And we're going to change this depending on what our current status is. So first, if active game is equal to null, if active game is equal to null, or again, we can just say, if active game gives me a faulty value, negate that. So this is the same thing as saying, is active game null? In that case, we're going to set our inner text to be no active game. Otherwise, if player, how are we doing this? If active game dot player 2, just make sure that this is how it comes back. Okay, so what we want to do next is we want to check if there is a game that they have joined, but player 2 isn't in yet, which means they're waiting on an opponent to join. You'll notice that when we return our state, we're just returning the name of the player, not the whole object. So we'll just check if active game.player2 name is not defined. Status or text is equal to waiting for text. All right, and let's leave that for now. And let's go back up here to where we updated the header. And let's set active game to be something here to do, just so that it's not null and we can see that the header actually changes. All right, there's a lot of stuff in here. We're going to npm run dev to see if this works. So our socket connects, no problem. If we go here, we reload the page. Great, so there's no active game because active game is currently null. We can connect as Eli, we can connect to the room A. And it's not going to work. This is great. Oh, it's because we crashed. All right, so we assigned to a constant variable, which was on line 28. We said that player num is a constant, which is not allowed. So we need to make this a let so that it can be changed. I think that should be it. npm run dev. Restart Eli. Hey. That didn't work either. We have another error. New game is not defined. All right, we're going to split this up here. So what I had down here was this line, which tries to get the current state of the game, but we don't actually have a reference to the game here. We only have a reference inside each condition. So we're just going to do this game.current state, or in the other one, we called it new game. Current state. We need to also move the socket join. This is not good coding practice. Don't do this. These are exactly the same. There's a better way of doing this, but we don't have time to think about it. Okay. So now if it creates a game, it'll join them, it'll update. If it joins, it'll join into the room and update. Let's try this. Act as Eli. All right, so now we've assigned to a constant variable in our front end. So that's cool. So main.js, all these things up here need to be let's game code, player num, active game. Everything else can stay constant. Okay, so now it actually worked. I don't think we printed anywhere, so we're not going to see it, but it came back. We got a true value that it was able to successfully create the game. And we put something in an active game, which means that update header now sees something there and says we're waiting for an opponent, which is cool. So we need to actually create a listener for update games, because right now we don't have any way of getting those updates, which is why we're just putting in this temporary thing. So we can also listen for events on our socket client too. We don't just have to listen on our server. So down here, we have a reference to our socket. And let's, I don't know, we'll just pick here arbitrarily. Let's not do that. Let's put it underneath our active game stuff here. So socket.on, and we called the event update game. And then what did we pass ourselves with the update game events? So we just send one thing, which is the current state of the game, which is an object. So that's all we'll take. All right, and we're going to make a separate function to handle this because I think that will be a little bit cleaner, and then we can reuse it, which is great. And we'll go ahead and scroll way down to the bottom here. Function update game. Use state. Great. So now when we get back an update, it'll just automatically call this function that will go ahead and modify our HTML. And we'll do some stuff. All right, let's run through this really quick. I think I've already lost most of you anyway. All right. So let's do this. Let's go ahead and clear our board first, and we're going to do this. Let cell of document dot query selector all dot cell dot remove, which takes it out of the HTML page, for let square of document dot marker query selector all marker dot remove for let square of document dot query selector. Oh no, this is all we want here. All right, so we've done this. There's a couple things that we want to do here. So first, we want to check if our new state is null. So if null, that means we're just going to clear the board and nothing else. So if new state is null, then active game is equal to null player num is equal to null. Game code is equal to null. We're just going to clear everything out and we're going to return. If it is not null, then we need to do a couple things. We need to insert markers where they need to go. If the game is over, highlight winning cells. So we're going to do this as a loop. And we're going to make this an enormous loop of lots of really cool things. X equal to x equal 0, x is less than 2, x plus plus. All right, so we're going to go ahead and insert markers wherever they need to go in our game states. So if x is 0, we're going to, what am I doing here? This is not right. Sorry, I lied. We'll get rid of this one. So we're going to look in our new state dot, we called it game state. And this is going to be our two-dimensional array. That's GS equal to. So if GS is equal to an X, then we'll go ahead and insert an X. Otherwise, if GS is equal to an O, we'll insert an O. Otherwise, we won't do anything. And this is kind of long. So we're just going to breeze through this. Let marker is equal to document dot create element of type image marker dot class list dot append marker, which means give it the class marker. Marker dot source is equal to dot slash x dot svg, which is what we call this asset up here. Document dot get elements by ID, and we'll leave this for a second, and we're going to append child marker into that. So where are we appending this to? We want to append this to wherever, whatever cell we think it needs to go in. So marker dot style dot display is equal to, actually, we don't need this. This is a relic of when I was doing this previously. So we need to figure out which cell we're going to put it in. And our cell is defined by this ij. So you'll remember that we called our cells 0 through 8. So we can do a little bit of math here. So our const cell num is equal to I times 3 plus j. So if I is 0, it will just multiply and be 0, and then we'll go to 0, 1, 2. If I is 1, then we'll go to 3, 4, 5. And if I is 2, we'll go to 6, 7, 8. So with our cell number, we're going to get whatever is in that cell, and we're going to append the marker to it. And we're going to do the exact same thing down here. Again, this code is duplicate, so this is not a good way of doing this. And we'll append o.svg. Okay, so right now we have just rebuilt our board. We have torn it all down. We're taking all of the markers out, marker.remove. We're turning everything to red. If we previously said that someone won and turned it to green, which we're probably not going to get to at all, we're going to turn it back to red. And that's what we got. So it should insert our things. But again, we don't have any way of playing the game right now. So like the game state is never going to change. So what we need to do is we need to go back to higher up here where we iterated through all of our cells. And then we said, are we clicking on one of them? And we said, we have no way of handling this right now. So let's wait until we do. And now we do. So we're going to do socket.emit, play move. We're going to send whatever the current game code they are in is. We are going to send their player. Actually, we don't even need to send that. Do we need to send anything else? I don't think we need to send anything else. They move code. We need to send a location where they're going to move it. And so I've defined this as an array of two things. The first one is the row. The second is the column. So cell ID equal to cell dot ID. And we're going to make this a number because this will be a string by default. All right. So now that we have this, we can do basically the opposite of what we just did. We can get the cell ID divided by 3. And this will give us back a floating point number. So we need to math.floor, which means round it down to 0 or 1 or 2. Cell ID mod 3 gets the column in that row. And so we're sending this as a location. And again, let's send a callback. And if success, console.log, made move successfully. All right. So we have just submitted our move to the server, which is not currently looking for it. And this will be the last thing that we do today. I think it should be playable. There'll be lots of bugs and lots of things that you should do to foolproof it to make sure that no one can do something that is illegal. But we're going to skip all of that because I'm way behind. All of this code that I've written, where I'm sure that I've lost most of you, is available on the GitHub, so you can go back through and actually figure out like why everything is there. I try to put some comments in to be helpful about like why I made certain decisions. But if something comes up that you're confused about, of course, just reach out to me on Discord. But what we need to do is we need to listen for that play move event. Socket.on play move. And we sent the code. We sent the location, and we sent the callback for if it works, send us back something. All right. Let me just make sure that I get everything in here that we need. All right, so we're going to do a couple things here. We're going to check if the code is null or game doesn't exist. We're going to fail. If the game exists, but they aren't a player, fail. If they're trying to access a game that they are not in the middle of. Otherwise, we go ahead and play the move. Call back whether it worked or not. If it worked, update with the new state. If the game is now over, remove the game. All right, so we have a lot of things to do here. Let's take this one at a time. So if the code is null, if code does not exist, or active games.has code is not true, then we will call back false, which means it did not work, and we'll return. The next thing we need to check is if the game exists, but they aren't a player. So at this point, we can safely get the game. This game is equal to active games.get code. So if this this game.player1.player ID is not equal to socket.id, because again, when we created our players, we sent the socket ID they're connected through as the player ID so that we can identify them uniquely. So if it is not player one, or sorry, rather we want an and statement here, I think. This game.player2.player ID is not equal to socket ID. And here we will also call back false and return that it didn't work. Are you in here after us? Okay, give me 5 minutes and we'll be out of your hair. So sorry. All right, so we got this. Now we need to go ahead and play the move. I'm just going to speed through all of this stuff here. So once we've done this, const player num is equal to game.player1.player ID is equal to socket ID 1, otherwise 2, so ternary. And const new states is equal to this game dot play move player num location. Great, and so this will return a couple things. If new state is not defined or it's null, then we will call back false, return. Otherwise, we will go ahead and io.to code.emit update new states. And the last thing down here is if it worked and the game is over. So if new state.game over is true, then io.sockets leave, which kicks everyone out of the room. Active games dot delete code. And at the very end of this, we will call back true. Sorry, this should go down here. All right, so theoretically, this will go ahead and do a bunch of stuff for us. Let's do one more thing here. Else if active game dot active player, what did I call it? I called it, yeah, active player is equal to player num status dot error text is equal to your turn. Else if active game dot active player is equal to player num. This is not true, then game status dot inner text is equal to opponent's turn. Okay, so this is everything that I want to do in here. This may or may not work, but this is all the code that theoretically should be enough to play. So I'm going to go ahead and move this for a second. Localhost 3000. So we can connect from 1. Eli will connect to room A. Have we already broken it? We have not broken it. So why isn't it working? All right, so this is a non-functional result. Something in here is not working correctly, and we do not have any more time to debug this. So this is unfortunately the reality of creating a bunch of like socket applications, creating games. There's a lot of interactions that you would expect to work that just don't. And so part of the hard part here is after we've created all of our infrastructure, there's going to be a lot of stuff in here that just doesn't work or doesn't work as you expect. Maybe you play a move, but you're not supposed to be able to. And so going back and trying to figure out like, where is the socket failing? Is something not getting passed correctly? Is the game rule logic just not working correctly? Which in this case, I've already debugged most of that for you since we copy and pasted it in. But this is the last step here. So we have everything. We have a front end that serves everything. We have a server that actually runs our sockets. We have our sockets that handle the real-time connection. This is your full stack of some sort of application. People specialize in one or the other. Our layout that we created is very simple, which is why I didn't make you guys do it. But you know, if we wanted to create like a multi-page application, that requires a lot more time investment. And so that's when people will focus on front end in particular, or use some sort of framework. If you're interested more in like the logical elements, like handling the game logic, handling storage, like we didn't use the database here, but if we had anything that were persistent, you would need to use some sort of database storage. That's when people focus specifically on backend. But in either case, you definitely need to understand how they work together so that you can do your job correctly. You can send the data that your front end wants, or you can request the data that the back end provides. So having an understanding of everything, even if you're not technically a full stack developer, is really important. All right, that's it. We got to clear out of here. This is the first week that anyone has come in after us, which I was not expecting. Thank you guys for being here. Before you go, there's a workshop feedback form on the link tree. I don't think anyone has filled it out yet. Just humor me. I know that it did not go well, but I would be curious to see what you guys have to say if there's anything that could be better. And so we can send that to our data team. All that being said, have a good weekend, everyone. Thanks for coming.
Thank you.